All right, now on to part 2. So, when a sample does not, let me erase this now. Okay, sorry about that. When a sample does not accurately represent the population, it's called a biased sample. So if we just took 7th grade, that would be a biased sample, okay? What is the population, the farmer or the tomato plants? Well, we're counting the number of tomatoes on the plants, so it's the tomato plants. The farmer is not the population. Unless we were taking farmers who grew tomato plants, that could be the population. But in this case, we were counting how many tomato plants there are. And what is the sample? Well, is there 10 tomato plants or 100 tomato plants? Well, we took our random sample of 10 tomato plants because we didn't want to count the entire population of tomatoes. Which method of sampling is a random sampling? All right, so to answer these questions, let's look at this. Okay, which method of sampling is a random sample? So a random sample, again, is a sample in which every person, object, or event has an equal chance at being selected. So when we took that first row, is that a random sampling? No, because not every high population tomato plant has a chance of being chosen. So choosing tomato plants at random is random sampling. Okay, because you might just as easily choose a lower producing tomato plant or a higher producing tomato plant. Which method of sampling could be a biased sampling? Choosing the first row is biased sampling. Okay, again, you can do biased sampling. It's just not going to give you as good a readout as if you did normal random sampling. It's possible it could, but it's likely that it won't. Okay, so these are rules that are made to be broken. Determine whether each sample is a random sample or a biased sample. So explain your reasoning. Roberto wants to know the favorite sport of adults in his hometown. All right, so we want to know, is this random sample or biased sample? Those are our two options here. Okay, he surveys 50 adults at a baseball game. Do you think this is a random sample or a biased sample? I'll let you think about it for a sec. Okay, and then the answer would be biased. Right? Why biased? Well, it's biased because he's choosing people that have already a like for baseball. Okay? If you went to a basketball game, his results would probably be different. If you went to a bowling alley, his results would be different. So this is a biased because, and again, a lot of you are forgetting to explain your reasoning. It's great that you tell me the answer. I want to know why you think that. Because he chose an event where people most likely enjoy baseball. I know my writing stinks, but it's okay. I'm saying everything out loud. All right, Paula wants to know the favorite type of music for students at her school. She surveys the first 60 people who enter the school doors in the morning. So, is this random sampling or biased sampling? What do you think? Right, it's random sampling. She is choosing 60 people at random. Okay, now people that get there early aren't likely. Part of me wants to say, oh, this is biased, and you might be thinking that too. But just because people get there early doesn't mean they're going to like a certain kind of music, all right? Music taste isn't correlated. There's no connection between music taste and how early people are. So the first 60 people aren't going to like classical music or trap music or something like that, okay? So that's what makes it random. Okay, and we're almost done, so I gotta go. You wanna know which radio station people in the neighborhood listen to the most? How would you get a random sample? So, how would you do that? Okay, I'll let you fill that one in. You can go door to door. You could send out a Google form. There's a lot of different things. All right, last example here. A shipment to a warehouse consists of 3,500 MP3 players. The manager chooses a random sample of 50 MP3 players and finds that 3 are defective. How many MP3 players in the shipment are likely to be defective? Well, let's just go through. A, it's reasonable to make a prediction about the population because this sample is random. It says it in the problem. Determine what percentage of the sample is damaged. So 3 out of 50, all right, they doubled it to 100, so 6, and that is our percentage, right? So 6% of the MP3s are damaged. Remember, if a number is over 100, then that's a percentage. Find 6% of the population, which is 6% of 3,500. Okay, so we're gonna do 3,500 times, how do we convert that to a decimal? We move the decimal over 2 spots, so it's gonna be 0.06. Okay, I'll do that right here. 3,500 times 0.06, 30, 21, move it over 1, 2, 1, 2. So 210 are defective. You could also set up a proportion to make a prediction. Defective MP3s in the sample, the size of the sample. So, defective MP3s, size of the sample. Defective MP3s in the population, this, over the size of the population, 100. I'm sorry, that was percentage. So this would be more like 3 over 50 equals blank over 3,500. And if you solve those for the proportion, you would get 210 right here. You'd figure out, okay, I need to multiply this by 70 to get 3,500, so I need to multiply this by 70 to get 210. Okay, and that's written down here. Boom. Okay, you could also say divide 50 by 3 and then get that number, and then divide 3,500 by whatever number you find, and you'll get 210. Okay, not as finished as I thought it was. Okay, yeah, you can use estimation because it would make things a little bit easier for you. Let's go on to number 4 so we can get out of here. The manager will want to use a random sample to present the entire shipment. One way to simulate a random sample is to use a graphing calculator and generate the random integers. To stimulate, all right, we don't really have graphing calculators, so I can't have you guys do that one, which is quite unfortunate. Okay, so you can create this chart on a separate sheet of paper, copy the table and record your results. You would need to collect a sample of 20 light bulbs. We don't really have that opportunity right here, so we can't do that. But you can use the tips that we use in order to get your answers for these. So watch this video over a couple times. Good luck, and we'll be getting into, well, this is basically it for mean, median, mode, range, and all that. All right, good luck.